Um, the, we had that little discussion at the end of the exam, and it was about fish and the fact that, well, fish appear to be a little bit more clever than we have given them credit for. So when we, I think I showed you, let me see if I can find it. I'm sure I can. Here we go again. I'm not going to do this again. We already did that. So, communication. Now remember, I guess we're biased in how we communicate. Why are we biased in the way we communicate? How do we normally communicate in here? Huh? Language, right. But we don't always communicate that way. So in general, communication, you have to be passive of information and use any kind of way to send it, whether it's visual, auditory, olfactory, all kinds of different ways. You have to have transmission of information that is benefiting the signaler, and it's intentional. And usually it's benefiting, oftentimes it's benefiting the receiver as well. So if we're communicating in here, and we're trying to be truthful, let's say, and we're trying to communicate honest information, then we're both getting benefit from it. Now, even if it's an antagonistic interaction, well, tell me about an antagonistic interaction where it's good for both the benefit of the signaler and the receiver, but it's actually antagonistic among humans. What do you do when you signal someone that you're unhappy with? What? Okay, flip them off. You might take this and slap them over the head, right? Now, the thing is, that's an honest signal. Both are on the same page, right? They're both understanding, oh, I'm pissed off at you, you understand, and maybe you don't understand what you did, but anyway, it's pretty apparent, okay? Now, sometimes, think of another situation that's antagonistic where the signaler is transmitting information that he wants to signal, but it's not actually apparent to the receiver. Sarcasm. Yeah, they might get that though. Okay. Yeah, it depends on, we'll say, the cognitive ability of the receiver. Yeah.
Like a magician, how it uses misdirection to put your gaze on something.
That's a great example. So, deception, right? That's an intentional transmission of information that you want to give to the receiver, even though the receiver may think it's one thing, but it's actually another. And deception, of course, can you think of any examples of deception among, let's say, animals in nature?
Mimicry.
What?
Mimicry.
Mimicry. That's a great example. Exactly. So, mimic another animal. Let's say you have a monarch butterfly that's toxic to a predator, let's say a bird. And you have also a model, a mimic model. It's called a viceroy. It looks very similar. What kind of coloration do, let's say, animals that are toxic, what kind of coloration do they usually have?
Bright.
Very bright. In fact, if they were cryptic, it wouldn't be so good, would it? It would defeat the whole purpose. So they're very bright. And of course the viceroy is deceiving. Who's the viceroy deceiving? It's another kind of butterfly that looks just like the monarch. Deceiving the predator, right? Might be a scrub jay or something. Because the scrub jay doesn't want to eat it because it thinks that in fact it's actually a monarch and it's going to be distasteful and it'll probably, throw it up or something like that. So, there's deception everywhere. But there's also times when you really want an honest signal. So in the case of the monarch butterfly to the predator, they're making it very clear. I mean, there's no unambiguity, even though maybe the predator hasn't learned to avoid such a thing. But there's generally no unambiguity in terms of the signal. It's right there in front of you. And if you're dumb enough not to take it, that's your problem. Okay? So, here we have a cheetah spring. What's the signal here? What is it, first of all? What's the ultimate signal? What is it doing? Marking territory. Okay. And then, what kind of a signal is it? I mean, we can see it, but generally, what kind of a signal is it? Chemical, right? In fact, a few years ago, we had an incidence of territory marking on campus here. I guess one, was it here, or I think so, yeah. One professor didn't like another, and so he went to the office of the other and peed on his door.
Wow.
Yeah. So, I don't know how quickly it took for the other professor to figure it out, but anyway, it did. I think did he get fired or?
The alternative hypothesis was that he liked it.
Oh, that's true. You're right. In fact, that's a good point. Thank you, Bobby. No, it could be, of course, that they're signaling that. So this signal here is, let's say, a male or a female giving a signal, but it could also be to the opposite sex. Okay, it's my territory, of course. Birds do it all the time, right? Males, let's say the song we just went through that with males and proximate behavior, their audio signal is often for other males in the area. It also can be, obviously, for females, too. It serves a dual function. There are sometimes differences between those different signals, but sometimes they're the same. So in this case, it could be that, I like you. And it could have been that in terms of the professors. It didn't play out that way, though. So in terms of function, signals obviously contain information that animals want to reveal because it either benefits the animal, but not necessarily the receiver. I mean, even with like the handicap principle and honest signals, well, if you can cheat, that's good. I mean, you can get away with cheating. You don't have to pay the cost and still derive the benefit. And humans are, of course, in terms of sexual signals, are really adept at cheating. We always try to put our best foot forward, so to speak. So I kind of gone through this. We have language. Now there's a fair amount of dispute whether other animals actually have language as well. But in terms of what linguists would define as language, other animals don't appear to actually have language. But they often communicate signals that are very specific to differences in their environment. So think about different kind of predators that, let's say, a ground squirrel might actually come across in its environment. What's probably the one that really freaks it out the most? A hawk. Okay. What other kind of predators are in the environment?
Cats.
Huh? Terrestrial. Anything else?
Cats.
Huh?
Cats.
Terrestrial. Fossorial. Any fossorial? Hey, who went on the trip to Ashton Canyon? Okay. What else did you see there that sometimes went underground to chase things? Snakes. Okay. And also other lizards as well. Okay. So there's different kinds of predators. Now, at one point it was probably thought, you know, an animal sees a predator, yikes, and that's it. That's the only information that's actually being dispersed. But that's not actually the case. There are a lot of animals that are very specific to different kinds of predators. I talked earlier in the semester about primates and snakes. And a lot of, besides humans, a lot of other monkeys, like the rhesus monkeys and different kinds of macaques. Primates are just kind of, they're obsessed with snakes, whether they're afraid of them or just highly vigilant towards them. Well, there's real specific kinds of signals that animals make. There's these wonderful ground squirrels, actually a lot of different kinds, but there's round-tailed ground squirrels down in the Sonoran Desert. And when a snake comes along, they oftentimes gather around it and beat their legs and twirl their tails and get very close to it, whether it's a venomous snake or not. So they're making, when they're doing this, they're making a visual display that other round-tailed ground squirrels are hip to. And a lot of times, they generally form colonies, and a lot of times there's group members, and they all know who they are, and they all kind of, it's called mobbing behavior. We've talked about it earlier with, let's say, owls or other bird predators and other birds coming in and mobbing and making a whole display, visual and auditory and whatnot. And these ground squirrels, they make a visual display. Now, there's been some real interesting work done in terms of how specific the information is for, let's say, different kinds of predators. There's a guy, I forget his name, but he works with prairie dogs. And they're very specific in terms of whether it's a hawk coming in or a coyote, whatever it is, a snake, same sort of things. But they're even more specific than that. The researcher and his grad students, he started seeing things that indicated that perhaps they were aware of individuals. So he did a little experiment. He had a grad student. It's a big guy, expressive. And the prairie dogs didn't particularly trust this fellow. And they made specific kinds of sound. And this guy, he generally wore the same kind of stuff he always wore in the field, kind of a field suit, let's say. And dressed the same way, had a baseball cap. And so the researcher decided, okay, I'm going to have another grad student dress as this other guy did. And let's see what the actual response is. And he had done a whole bunch of auditory recordings of different kinds of responses. And so this other student went through and kind of got the same response as the one that the prairie dogs were actually kind of reticent about. There were other grad students that they, it was like, oh, this one's safe. You don't have to worry about this one, even though the one that was causing all the ruckus was not the meanness. Well, maybe the researcher didn't realize it, that the other guy was actually being mean because he was being dissed by these rodents, and that's not really a nice thing to do, even to a grad student. Do you think animals have a more limited repertoire of signals than let's say humans do? Or a greater repertoire of signals? Any ideas? What can some animals do that we can't in terms of signals?
Smell better.
Huh?
Smell better.
Yeah. A lot of animals have better olfactory senses.
Mercury.
Better hearing, better visuals. They may not have language, of course, but they have, we might even call it, I guess, proto-language. Obviously, you would think that language didn't spring in humans just from nothing, like de novo. It obviously descended from an ancestor that had some form of early language. Perhaps it wasn't vocal, it might have been gestures. So if you go to different places in the world, you know that some people, some groups of people are very taciturn, they don't use much, but others do. They're all over the place, like, you know, Italians, let's say. Oh, mon ami, che pazzo, che pazzo, che pazzo, why are you so crazy, right? Okay. Sometimes signals are very specific. They only mean one thing. But as we've seen with proximate signals like with birds, and whether it's to other predators or to other of the same species, signals can have many meanings. And sometimes those signals are actually different. There's a bird called a widow bird, and it's another, I think it's another nest parasite. But anyway, the males have, one of the species has a long, very long tail, and he also has a very bright red head. And the long tail is actually for the female response. So a male with a longer tail finds that more attractive than a male with a shorter tail. And they've done this, they proposed this hypothesis, and they did it by extending the tail of certain male widow birds with longer feathers, or and then the other treatment was leaving them normal, or then chopping them down and regluing them. And they found, in fact, that females responded to the long tails. But the head was a different story. The main target, or receiver in this case, was, what do you think? Other males, or, well, that's what it was. It was other males. So you may think that a signal is for a specific receiver, but you can't necessarily jump to that conclusion. Sometimes there's very clear separation, and then other times there isn't. A lot of songs, male songs are actually to both. So just real simple, you need a signaler and obviously a receiver. An animal that sends out a signal. A signal is a message. It can be any kind of a signal in any kind of mode or form. And of course, the receiver is the animal that receives a signal and whose behavior can actually be influenced, whether for its benefit or not. It's often, of course, for members of its own species, but some signals and messages have evolved to communicate with other species. So, we'll think about the widow bird again. I'm not sure if it actually does this, the male does this or not. But let's say the bright head, very conspicuous. Having a bright head and having a long tail makes the bird conspicuous. That's great, let's say, if you're dealing with other males in other territories, displaying for females, or if you're displaying for females. But what about predators? Is that such a great thing? Let's say having a very conspicuous display. Okay. Can you think of an instance where actually having conspicuous display for a predator might be actually beneficial? In fact, you're providing an honest signal to both the predator, the receiver, and the sender.
Was it dark frogs?
What?
Was it dark frogs? Was it dark frogs?
Okay. But in this case, usually when we think of sexually selected traits, we think of the fact that they're usually beneficial in terms of reproductive success, but less so in terms of survival. Usually these signals make an animal much more conspicuous to predation. But is that always really the case? What if the signaler actually knows there's a predator there and signals that, oh, hey, how you doing, Putty Cat? I'm here. What are you going to do about it? Well, it's actually, he's sending a signal for the predator that don't waste your time. You know, you may, I mean, at other times I might be, my brain might be preoccupied with women, right? But in this case, I see you, you see me, there's no point in attacking me, you're just going to waste your energy. So that's actually an honest signal to predator. Now, of course, you can't assume that. You actually have to test it. I guess one way, there's these animals, there's a lot of cervids, deer, antelope, things like that. They do something called pronking, where they kind of jump up in the air, or stoating. They appear to do it sometimes for other reasons. Oh, never mind. But sometimes they've actually done studies in terms of, let's say, cheetahs with gazelles, and the gazelles pronk when they, let's say, see cheetahs. Now, of course, you could say, okay, there's a whole bunch of different hypotheses that might be for pronking. It could be to indicate to other members of the group, well, that there's a predator around. So in that case, you would expect that they would only pronk, let's say, when there's other members of the predator around. What would you expect if it wasn't really for other group members, but it was for the predator himself? When would they usually pronk? When there's a predator. Irrespective of whether there's group members around or not. Okay? Whereas the other hypothesis, of course, is that if they're, let's say, displaying, it could also be sexual selection display, males for females, saying, see what kind of condition I'm in, I can pronk like with the best of them. So they would make different predictions. But if it was, let's say, warning to other members of the group, then in that case, the prediction is they would only display when other members were around. Versus, if it's a predator, specifically, it would be irrespective of whether there's other members around or not, but there's always a predator present. So you could actually that's how you would actually test the hypothesis. Of course, this is observational. It's not a controlled experiment, but it gives you at least a weak inference that something is going on here. I'm sorry, let me turn this off. Okay. So, we were talking about usually for members of the same species, but not always. So, alarm calls and warning signals, obviously, for other animals. Communication is most often adaptive, or often adaptive, to both the sender and the signaler. In other words, it contributes directly to each individual's fitness. And that even includes antagonistic interactions like between a prey and a predator. Whether it's warning coloration or some actual behavior with the gazelles and the stoating. They're actually, the guys, you know, the gazelle is actually saying, don't waste your time. Time is money, that's what, as we say. So, senders and receivers they must have obviously the appropriate structures to send and receive the signals and messages. Talked about aposematic coloration, warning coloration, found throughout nature. In fact, the basic pattern is there's usually some high contrast color against another, whether it's white and black or yellow and black, something like that that really stands out. It's not a voluntary signal that you make, it's just part of the morphology. You don't want to have to think, oh, I want to display this way. It's just there for all to see. So, on the bottom, on the right, are the poison dart frogs. They're all one clade, and in South America. They use a kind of toxin, I think it's called Basat. What is it? Body? Basat or Chax? What's the kind of toxin it is? Yeah. Okay. It turns out it's a fairly common toxin, not just with these frogs, but other animals use them too. You probably haven't heard of these, but on the lower right are these birds called pitahuis. Pitahui? They're from New Guinea. You don't find them anywhere else. They were discovered, I don't know, probably 20 years ago, maybe 15, something like that. And they inadvertently found out, in fact, that they were toxic birds. Because there were a bunch of ornithologists in Guinea, and they were mist-netting. They set up nets to see what was there. Usually there's a long-term banding effort, so a lot of times they'll put bands on the birds so they can identify recaptures and whatnot. Well, they sort of noticed, some of the researchers started noticing, especially the banders, the one that were really doing it a lot, that they weren't really feeling all that well. And it turns out it was the same kind of toxin. I mean, it's slightly different, but same kind of chemistry that poison dart frogs use. So it's actually a toxic bird. As you can see, they have aposematic coloration too. I don't know how many different species there are, but there's a fair number, and they all have very bright warning coloration. When you have aposematic coloration, I mentioned the viceroy. What could you predict in general about, let's say, warning coloration and animals and other animals that are not being honest? What? Mimicking, exactly.
I have it, but
Yeah. And in fact, same thing is happening with these birds. They're actually unrelated mimics that look like it. What kind of evolution is it when you end up with the same sort of characteristic or trait?
Convergent.
Huh?
Convergent.
Convergent, right. In fact, that's what mimicry is really all based on, for the most part, yeah.
Like with the poison dart frogs, they actually lose their toxicity or whatever, their poison when they're not given, I don't know what food exactly they eat, but their native food is, because I volunteered and seen them and stuff.
Yeah.
But, so
It's
why do you
ants.
think that ants?
Yeah.
Why do you think that when they're taken out of their own environment,
Mm-hmm.
they don't need to communicate that signal anymore? Or do you think it's solely just the they don't have the food, so they don't produce the toxin?
Yeah. I mean, there's a lot of dietary signals that you find in, let's say, honest signals between birds. There's a bird here called the house finch. The male has a bright red head. The basis of that coloration are chemicals called anthocyanins that are found in a lot of different plants, especially seeds and things like that. And the brighter the head, usually it's because of diet. It's also kind of an honest signal in that not only is it just, it shows, oh, I'm brighter, I can handle the predator pressure, perhaps if there is any, but it actually varies with diet. And so males who are not as adept at foraging and efficiently as others, or they live in a territory that doesn't have that food with a lot of anthocyanins in it, they usually don't have such a bright red head, and a lot of times they're kind of washed out, orangey or yellowy or something like that. Now, the poison dart frogs, I'm not sure what the basis is for the color. I'm unsure about that. As far as the basis for the toxin, the precursors to producing the toxin in the frogs is ants. It's various chemicals that they eat from ants, because that's their primary foraging. So that's another, obviously, if you're not getting enough ants of, let's say, the right species or whatever, you're not going to be producing the same toxin. It also, there's a cost. What's the cost of producing a toxin? Is it expensive or cheap?
Probably expensive.
Yeah. Under what ecological circumstances would it be advantageous to produce a toxin versus not producing a toxin in terms of predators?
A lot of predators.
Yeah. So if there's a lot of predators, you predict, of course, that you'd have the poison dart frogs would be very toxic. If you found related species in areas where there weren't, let's say, any predators, normal predators, oftentimes you see kind of differences spatially. A lot of plants are this way. You'll see one of the favorite toxins of plants is a cyanide-based compound. All kinds of different, I mean, cyanide is HCN, right? Hydrogen, a carbon, and a nitrogen. And there's plants use all kinds of things that are either start out that way or actually are compounds that when they're broken down either with a catalyst or just part of the normal metabolism. Well, in some areas where the primary, this is kind of off the topic, but the primary, let's say, predator isn't around, then you'll see in a lot of cases where they just won't produce it at all. Or they won't produce it at all until all of a sudden a plant starts getting eaten by an herbivore, and then they start producing it. So obviously it can be expensive, even though it's a fairly simple thing. But nitrogen is generally kind of a limited quantity. So we're very visual. Of course, we use auditory a lot because of language, but obviously there's visual signals and displays, auditory, there's chemical signals, all different kinds of chemical signals. We were talking about prairie voles versus meadow voles. One's polygynous, one isn't. Probably one of the cues in terms of prairie voles that have basically monogamous relationships for the most part. They probably emit chemical cues that the males pick up on, and vice versa. A lot of insects use chemical cues in terms of identifying mates and pheromones, all that kind of stuff. And then, of course, there's chemical signals for all sorts of different things. Skunks, scare things away. Tactile signals. Just think about yourself. Is touch important in your relationship with other people? I'm not, just generally. We're social animals. Is touch important?
And it sends, signals to your brain too that associate with bonding.
Exactly. So, if you just think about the way we're wired in terms of our touch, it's extraordinary how we're wired. And it's if you're a social animal where bonding is very important, you can see touch in humans is it's just extraordinarily beneficial for the most part. Okay? And obviously a lot of animals have that kind of wiring, even if they're not social necessarily, but they still respond. And then there's others. There's other kinds of signals. So, electric. Electric fish. They use it as a signal, but they also use it as a weapon as well. Electric fish. A lot of animals use sonar. They use it oftentimes for signaling as well as between each other as for actually, let's say, finding prey. So we're going to look at bats and moths and the interaction that's developed between those two groups of animals. But obviously there's an arms race going on there. And it turns out that the sonar, or echolocation we'll say it's called, bats use it amongst themselves. Bats use it to disrupt other bats in terms of trying to acquire prey by using it. You wouldn't think that moths are all that intelligent. They don't necessarily have to be. But they also communicate amongst each other with echolocation as well. And they do the same thing with bats. In fact, they're oftentimes deceptive in their signaling. There's some moths that can actually jam echolocation signals from other bats. Now this is predator-prey, but it's also communication. And bats use the same sort of thing to disrupt echolocation amongst each other if they're all competing for the same food item. And it's the same structures that are used in both. Okay, let's see if I can. Okay, you want, yeah, okay. He's gonna ask you some questions. Now, we've already had a talk about this earlier, right? So,
Paid them well.
oh, yeah, actually, they pay me well, but that's besides the point. Yeah, no, there's an understanding. So anyway, he's going to talk. I'll clean up this stuff after he's done.